Now I want to continue the scientific study part 2, and these are multiple choice question. Let's have the question. Number 1. Which of the following sequences clearly represents the fundamental units of quantity of matter, temperature, length and electric current? What do you think? Which one is correct option? Among gram, pound, candela and foot, which system do they respectively belongs to? Now, these are the options. Now, third question, which of the following is not a derived unit? These are the options. Now, I want to give you answer. Which of the following sequence correctly represents fundamental units of quantity of matter? Quantity of matter is mole. Mole is present in A, B and C. And temperature, degree Fahrenheit, degree Celsius, Kelvin. In all these A, B, C, unit of temperature is written. And length, light year is actually the unit of distance between stars and galaxies are measured in light year. And candela is not the unit of length, that's why we have to cancel number B. And the centimeter, yes, centimeter is the unit of length. Till now A and C exist. And electric current is measured in ampere, written in A, and in C it is measured in volt. This is incorrect, that's why we have to come back to A. This is the correct option. Okay, let's have second one. Among gram, pound, candela and foot, which system do they respectively belongs to? Gram belongs to CGS system, it is written in B. In other option CGS is not written, that's why B seems to be correct. Let's check it again. Pound, FPS system, yes. Candela is present in SI system, yes. And foot is present in FPS system, that's why number B is correct option. Now let's have 3. Which of the following is not a derived unit? Newton, joule, ampere and Hertz. Ampere is fundamental unit, it is not derived unit, that's why this is the correct answer. Let's have another set. Which one is correct? All units of the CGS system fall under the SI system, is it? All units of FPS system fall under the SI system. All units of both the CGS and FPS systems fall under the SI system. All units of MK system fall under the SI system. Okay, which one is correct? Here options are given A, B, C, D. And in question number 6, which of the following is a derived unit formed by multiplying a fundamental unit by itself? Look at, these are the options. Okay, let's take each of them. Number 4, which one is correct? All units of CGS system fall under SI system? No. All the units of FPS system fall under the SI system? No. Feet, pound, second is not present in SI system. Centimeter, gram is not taken in SI system. All units of CGS and FPS system fall under the SI system. This is also incorrect. Now all units of MK system fall under the SI system. Yes, M means length is measured in meter, K represents mass is measured in kilogram, S represents time is measured in second, and meter, kilogram and second, all these are taken in SI system. That's why number D is correct option. Which one is correct? Fundamental and derived units can be broken down into primary units. No. The reason is very simple. Primary units itself is fundamental units. That's why fundamental units cannot be broken down into primary unit. This option is incorrect. Derived units can be broken down into primary units. Yes, derived unit can be broken down into primary units because primary units means fundamental units and derived unit is made by using one or more fundamental units. C. Fundamental units can be broken down into primary units. This is incorrect. Neither fundamental nor derived units can be broken down into primary units. No. That's why we have to go through option number B. Option number B is correct. Look at number 6. Which of the following is a derived unit formed by multiplying a fundamental unit by itself? Each of them have the same fundamental unit multiplied by itself. But ampere square doesn't represent the unit of any physical quantity. In the same way, kg square, have you heard about this? Any physical quantity has a kg square is unit? No. A second square is also not the unit of any physical quantity, but meter cube is the unit of volume. That's why this option is correct. Okay, D is correct. Let's have another set. Number 7. Which of the following is a derived unit formed by dividing one fundamental unit by another fundamental unit? These are the options. Now, 8. Which of the following units is formed using only a single fundamental unit? These are the options. 9. Which of the following unit groups represents the fundamental units involved in gravitational constant? These are the options. Okay, now let's have number 7. Which of the following is a derived unit formed by dividing one fundamental unit by another fundamental unit? Is it Newton? No, Newton is not, because expanded form of Newton is kg meter per second square. It has not only 2 units, more than 2, and that's why we don't have to see this. Meter per second, yes it is, because fundamental unit of length meter is divided by fundamental unit of time second. That's why one fundamental unit is divided by another fundamental unit. This is correct option. But joule, Newton meter is joule. We know that the Newton can be expanded to kg meter per second square into again meter. That's why this is not, and Hertz is also not. In Hertz only one fundamental unit is involved. That's why we have to take number B. Okay, which of the following units is formed using only a single fundamental unit? Only single fundamental unit. Hertz, joule, Newton, volt. Correct answer is Hertz, because in Hertz only second is involved and 1 divided by second. A reciprocal of the second is taken as Hertz. Okay, now 9. Which of the following unit groups represents the fundamental units involved in gravitational constant? Now, you can get it by the help of an equation F equal to G m1 m2 by d square. If G is taken to left hand side and all other physical quantities are taken to right hand side, and each of them are if represented by their units and all the units are converted into fundamental unit, then you'll get the result this one. C is correct. You can do it yourself. Meter cube, kg to the power minus 1, second to the power minus 2. Let's have another set. Which of the following unit groups represents the fundamental units that make up the derived unit joule? Now these are the options. And another, which of the following operations are used in dimensional analysis of equations? Look at this, these are the given options. And number 12, which of the following statements is correct in dimensional analysis of equations? This one, this one, this one, this one. Okay, let's have question number 10. Which of the following unit groups represents the fundamental units that make up the derived unit joule? Joule means Newton into meter, and Newton, expanded form of Newton is kg meter per second square. It is given in B, but this is the expanded form of Newton, not the joule. And if Newton is multiplied by meter, if the same, this one is if multiplied by meter, then we'll have kg meter square per second square. Yes, that's why option number A is correct. Which of the following operations are useful in dimensional analysis of equations? Addition and subtraction? No. Multiplication and division? Yes. Addition, subtraction, multiplication, division, not correct. Addition and multiplication, not correct. That's why actually multiplication and division. Which of the following statement is correct in dimensional analysis of equations? It checks whether the derived unit on the left hand side of the equation is equal to the fundamental unit on the right hand side. Is it? No. It checks whether the fundamental units on the left hand side of the equation are equal to the derived unit on the right hand side. No. It checks whether the fundamental units on both the left hand and right hand sides of the equation are equal. Yes. In equation, what we do, at first we'll write the derived unit of the physical quantities present in both the side left and right, and then we'll break down this derived unit into fundamental unit in both the sides. And if fundamental units in left hand side is equal to right hand side, then we'll say that this equation is correct. This is the procedure of analysis of equation. Yes, that's why the C is correct option. It checks whether the derived unit on both the left hand side and right hand sides of the equation are equal. This is incorrect. Okay, let's have another set. Which of the following tasks cannot use unit analysis? These are the options. Okay. Now 14. Which of the following is correct? Number A, B, C, D. Okay, number 15. Which of the following unit groups represent the fundamental units that make a potential difference? Look at these are the options. Okay, let's go to 13. Which of the following tasks cannot use unit analysis? To verify the correctness of physical equation, we are using unit analysis to verify actually the correctness of physical equation. This is not the correct option. To determine the relationship between physical quantities, yes, for this purpose also we use unit analysis. To find the value of constants in physical equations, this is incorrect. With the help of unit analysis, we never get the constant value of constant. Just for example, kinetic energy equal to half mv square. Half cannot be obtained by unit analysis. That's why this option number C is correct option. Unit analysis cannot be used to do this task. Okay, to convert units between different measurement system, yes, we do this also with the help of unit analysis. That's why correct option is option number C. Which of the following is correct? In an equation, the independent variable and dependent variable are on the left hand and right hand side respectively. No, actually dependent variable is always towards left hand side, independent is towards right hand side. We have to search that. That's why option number B. In an equation, the control variable and dependent variable are on the left hand and right hand side respectively. This is also not correct. In an equation, the independent variable and control variable are on the right hand and left hand side respectively. This is also not correct. In an equation, the independent variable and dependent variable are on the right hand and left hand sides respectively. Yes, this is correct. Here what is told, independent variable in right hand side, dependent variable in left hand side. Dependent variable is always in left hand side. That's why option number D is correct. Which of the following unit groups represent the fundamental units that make a potential difference? For this, you have to go through one equation. Potential difference V equal to work done by charge W by Q. Q can be written as I into T because current equal to charge by time, and we have to write their units, and each of the unit has to be converted to fundamental unit, and lastly you get this result. You do this yourself. Okay, these are the questions. I told you the reason also. Just tick mark is not enough. These questions may or may not repeat in any examination, but the concept what is given here is useful in any examination. Okay, now I want to stop.